All right, in this lesson, we're going to discuss parallel lines and angles. First, let's discuss parallel lines. Parallel lines are coplanar lines that do not intersect. So what does coplanar mean? In geometry, a plane is a flat surface or section that goes on forever in all directions. So it's kind of difficult to imagine or draw a plane. So just imagine a sheet of paper as being your plane, even though it doesn't go on forever in all directions. So if you had two lines drawn on that one sheet of paper, then those two lines would be coplanar. If you had two different sheets of paper and one line drawn on each sheet, and one of the sheets of paper is on the floor and the other one's on top of your desk, then those two lines would not be coplanar. And then another way to express the fact that parallel lines do not intersect is to understand that parallel lines are equidistant. That means they are always the same distance away from each other. And since they're always the same distance away from each other, they will never intersect. So parallel lines are coplanar lines that are equidistant, that are always the same distance from each other, and they will never intersect. So when you're looking at figures of lines, the way that lines are often identified as parallel is by using these little arrowhead type figures. I'm going to draw them like this. Sometimes in books you'll see them filled in more triangular in shape. But you see how I am showing that line AB and line CD each have one arrowhead. I am identifying for you that they are parallel to each other. Then if I wanted to say that AC and BD were parallel to each other, then I could put two arrowheads on each of those to show that they are parallel to each other. So the symbol for parallel, when you're trying to write it as a statement, is two vertical lines next to each other. So for example, if I want to state that line AB is parallel to line CD, I could say line AB is parallel to line CD. And AC and BD are also parallel, so I could say line AC is parallel to line BD. Sometimes, as in this second figure here, lines are not identified by the points that make them. They only have one letter at the end here. So in this figure, you see that line E is parallel to line F, and the way I would write that is line E is parallel to line F. All right, the next concept is a transversal. A transversal is a line that intersects two or more coplanar lines at different points. So if I look at this first figure here with lines A, B, and C, none of these are transversals. Why? Because they all intersect each other at this one point here in the middle. So that's not what the definition of a transversal is. A transversal is a line that intersects two or more coplanar lines at different points. So if you look here at this section, you see that line D intersects both lines E and F at two different points. It intersects line E here, and it intersects line F here. So the transversal in this figure is line D. So when two lines are cut by a transversal, we have many different angle pair relationships that are developed. Some of these you can already identify from previous lessons. For example, linear pair. We know that a linear pair is a pair of angles that combine to make a straight angle or a straight line. So for example, angles 1 and 2 on the top or the outside of line B are a linear pair, and angles 3 and 4 on the bottom or the inside of line B are also a linear pair. Angles 5 and 6 on the top of line C are a linear pair, and 7 and 8 are a linear pair as well. And then we even have on either side of line A, we have angles 1 and 3 are a linear pair, angles 2 and 4 are a linear pair, angles 5 and 7 are a linear pair, and angles 6 and 8 are a linear pair. You should also be able to identify vertical angles. Okay, vertical angles, remember, are formed when two lines intersect and they are opposite each other. So for example, up here, where line A intersects line B, we have angles 1 and 4 are vertical, and angles 2 and 3 are vertical. And then where line A intersects line C, we have angles 5 and 8 are vertical, and angles 6 and 7 are vertical. All right, so interior angles are angles that lie in that region in between the two lines. So for example, this is the interior region here in this figure. And so our interior angles would be angle 3, angle 4, angle 5, and angle 6. Exterior angles are the angles that are in the region outside the two lines. So this would be the exterior region here. So our exterior angles would be angle 1, angle 2, angle 7, and angle 8. So consecutive interior angles are interior angles, so that green zone, right, that are on the same side of the transversal. So we know our interior angles are angles 3, 4, 5, and 6, but which ones are on the same side of the transversal? So angles 3 and angle 5 are both interior angles, and they are to the left of the transversal A. So that would be angle 3 and angle 5 are consecutive interior angles, and that would be angle 4 and angle 6 are also consecutive interior angles. Alternate interior angles are non-adjacent interior angles on opposite sides of the transversal. So if we look here in the green zone, the interior, at angle 3, we already know that angle 3 and angle 5 are consecutive interior angles because they're on the same side of the transversal. But if we look at angle 3 and angle 6, they are both inside in the interior, but they are on opposite sides of the transversal. So angle 3 and angle 6 are alternate interior angles. If you're wondering why you can't say angle 3 and angle 4, remember it says here non-adjacent, and angle 3 and angle 4 are adjacent. Look at the other pair. We have angle 4, and angle 4 is to the right of the transversal, and we have angle 5, which is to the left. So our other pair of alternate interior angles is angle 4 and angle 5. Alternate exterior angles are the same concept, except now we're dealing with the exterior. So they are non-adjacent exterior angles on opposite sides of the transversal. So we're looking at the yellow zones here. If we look at angle 1 is outside line B to the left of the transversal, and angle 8 is outside line C to the right of the transversal. So we have angle 1 and angle 8 are alternate exterior angles. And if we look at the other pair, angle 2 is outside line B to the right of the transversal, and angle 7 is outside line C to the left of the transversal. So our other pair of alternate exterior angles is angle 2 and angle 7. Corresponding angles lie on the same side of the transversal and on the same side of the two lines. So for example, angle 1 is to the left of transversal A and on top of line B, and so is angle 5. Angle 5 is to the left of A and on top of line C. So angle 1 and angle 5 are corresponding angles. Let's find the other ones. How about angle 2? Angle 2 is to the right of A and on top of B, and so is angle 6 to the right of A and on top of C. So we have angle 2 and angle 6. What else? Well, angle 3 is to the left of A and under line B. Who's its partner? Angle 7 is to the left of A and under C. So we have angle 3 and angle 7. And finally, angle 4 is to the right of A and under line B, and so is 8 to the right of A and under line C. So we have angle 4 and angle 8. These are our corresponding angles. So when two parallel lines are cut by a transversal, then these angle pair relationships that we've talked about develop a special significance. And all of these situations deal with two parallel lines cut by a transversal. So all of these start off with this statement. So if we take a look at the first one, the corresponding angles postulate. If two parallel lines are cut by a transversal, each pair of corresponding angles is congruent. So remember, corresponding angles are those that are on the same side of the transversal and on the same side of their lines. So for example, angle 1 and angle 5 are both to the left of A and on top of their line. So the corresponding angles postulate tells us that angle 1 is congruent to angle 5. What else? Well, how about angle 3 and angle 7? They're both to the left of A and under their lines. So angle 3 is congruent to angle 7. Now we have angles 2 and 6 are to the right of A and on top of their lines. So angle 2 is congruent to angle 6. And angles 4 and 8 are to the right of A and below their lines. So angle 4 is congruent to angle 8. The next relationship is alternate interior angles theorem. So that one states, if two parallel lines are cut by a transversal, each pair of alternate interior angles is congruent. So remember that alternate interior angles are inside the parallel lines, they cannot be adjacent to each other, and they have to be on opposite sides of the transversal. So we have angle 3 and angle 6 are inside the parallel lines, they're not adjacent, and they are opposite sides of the transversal. So this tells us that angle 3 is congruent to angle 6. What's the other pair we have? Angles 4 and 5. They're not adjacent, and they are inside the parallel lines, and they are on opposite sides of the transversal. So angle 4 is congruent to angle 5. The alternate exterior angles theorem is just like the alternate interior angles theorem, except we're dealing with the exterior angles. So it says, if two parallel lines are cut by a transversal, each pair of alternate exterior angles is congruent. So angle 1 is outside of line B to the left of A, and angle 8 is outside of line C to the right of A. So this tells us that angle 1 is congruent to angle 8. And then we also have angle 2 is outside of B to the right of A, and angle 7 is outside of C to the left of A. So angle 2 is congruent to angle 7. And finally, we have the consecutive interior angles theorem. This one's a little different. It says, if two parallel lines are cut by a transversal, each pair of consecutive interior angles is supplementary. Remember, that means that they add together to equal 180 degrees. Their sum is 180 degrees. So consecutive interior means inside the lines and on the same side of the transversal. So we have angle 3 and angle 5 are supplementary. So angle 3, let's say the measure of angle 3 plus the measure of angle 5, we know that that has to equal 180 degrees. What else do we have? On the other side, angle 4 and angle 6 are inside their parallel lines and to the right of the transversal. So angle 4 and angle 6 are also supplementary. So the measure of angle 4 plus the measure of angle 6 equals 180 degrees. So to summarize, corresponding angles which are on the same side of the transversal and on the same side of their line are congruent. So for example, angle 2 is congruent to angle 6. Alternate interior angles, which are non-adjacent angles that are inside the parallel lines and on opposite sides of the transversal, are also congruent. Example, angle 4 is congruent to angle 5. Alternate exterior angles, same idea, except we're dealing with the exterior. They are congruent. Example, angle 1 is alternate exterior with angle 8. So angle 1 is congruent to angle 8. And consecutive interior angles, those are the ones that are inside the parallel lines on the same side of the transversal. They are supplementary. So the measure of angle 4 plus the measure of angle 6 equals 180 degrees. So if I have two parallel lines cut by a transversal and I have the measure of one angle, I could use all of this information to find the measure of all the other angles. So let's say, for example, that angle 1 measures 60 degrees. Well, right away, I know that angle 4 also measures 60 degrees. Why? Because they are vertical angles, and vertical angles are congruent. What else do I know? Well, I know that angle 5 measures 60 degrees for actually two different reasons. Number one, because angle 1 and angle 5 are corresponding angles, so they're congruent. But I could also say, well, angle 4 and angle 5 are alternate interior angles, so they're congruent. And finally, I know that angle 8 is also 60 degrees. And I could use a bunch of different reasons for that one, right? Angle 8 is vertical to angle 5. Angle 8 is a corresponding angle with angle 4. And angle 8 is alternate exterior with angle 1. So those are all reasons why I know angle 8 measures 60 degrees. So now how about angle 2? Well, I know that angle 1 and angle 2 are a linear pair. So if angle 1 measures 60 degrees, then angle 2 must measure 120 degrees because they have to be supplementary. If angle 2 is 120 degrees, then angle 3 is vertical, so it's also 120 degrees. I know angle 6 is corresponding to angle 2, so it's 120 degrees. And it's also alternate interior with angle 3. And I know that angle 7 is vertical with angle 6, so it measures 120 degrees. Angle 7 is also corresponding with angle 3, and it's also alternate exterior with angle 2. So let's take a look at a few sample problems. Here it says, if the measure of angle 6 is 2x minus 17, and the measure of angle 1 is 85, then find x, right? So I know that angle 1 measures 85 degrees, and in order to answer this, I need to figure out what the measure of angle 6 is. So I could go about this a few different ways. What I'm going to do is, I know that angle 1 and angle 4 are vertical angles, so they are congruent. So if angle 1 measures 85 degrees, then angle 4 measures 85 degrees. Because they're vertical angles, and vertical angles are congruent. So now I know that angle 4 and angle 6 are consecutive interior angles, which means that they are supplementary. Their measures add to 180. So I can use that information to find angle 6 by simply subtracting 85 from 180. And I see that angle 6 measures 95 degrees. Now I can use that 95 to solve my equation. And my equation is 2x minus 17 equals 95. So I'm going to add 17 to both sides. And I get 2x equals 112. And then finally, I divide both sides by 2. And I get x equals 56. All right, next example here. Find y if the measure of angle 3 is 4y plus 30 and the measure of angle 7 is 7y plus 6. So if I look at angle 3 and angle 7, I see that they are both corresponding angles. That means they are congruent. So the measure of angle 3 has to be equal to the measure of angle 7. So we end up writing an equation with variables on both sides. So we have 4y plus 30 equals 7y plus 6. So first we have to get rid of the variable of lesser value. So I'm going to subtract 4y from both sides. And I get 30 equals 3y plus 6. Then we have to subtract 6 on both sides. And we get 24 equals 3y. And finally, divide both sides by 3. And we find that the value of y is 8. All right, one more example. It says find x and y. And this example is a little bit more complicated than the others. You may not know where to begin. So what do? Well, in a problem like this, you have to be like a detective. You have to look for the clues and then use those clues to find more information. So what do we already know? We know that the left side and the right side are parallel lines. So if I look at that here, and I try to extend these lines a little bit, so I'm going to extend this line this way, and I'm going to extend this way, and then I'm going to extend this bottom side this way, and this way. And what I can see when I do that, even if I didn't do a great job, is I can see that the left and the right are parallel lines, and that this bottom side of this figure is a transversal that is cutting two parallel lines, which means that there's a special relationship here between this angle here that measures 120 degrees and this angle here labeled x degrees. And it is that they are consecutive interior angles. And what does that tell me? That tells me that they are supplementary. So if this angle measures 120 degrees, that means that this angle measures 60 degrees. So now I know what x equals. X equals 60. Now what other clues do I have? Well, if I look at the top here, I can see that this angle here, 3y plus 40 degrees, and this angle here, 3x minus 70 degrees, form a linear pair, which means they are supplementary, that their sum is 180 degrees. So I can use that to write this equation here. 3y plus 40 plus 3x minus 70 equals 180 degrees. And I know what x is. X is 60, so I can substitute. So I have here 3y plus 40 plus 3 times 60 minus 70 equals 180 degrees. I know that 3 times 60 is 180, so 3y plus 40 plus 180 minus 70 equals 180. I can combine like terms. 40 plus 180 is 220, minus 70 is 150. So 3y plus 150 equals 180. Subtract 150 from both sides, and I get 3y equals 30. And then finally divide by 3. And I get y equals 10. So I know that x equals 60 and y equals 10.